Before we go on, let's think about issues that might make these functions even more usable. Suppose I stop working on vecop for a little while, and I'm working on some function over here, carve, which is unrelated. And then at some point later in time, I come back to vecop and I look at it, and I can't even understand what the purpose of vecop is. There's 5 lines of code. I don't remember why I wrote it. I don't remember what it's doing, and it just looks complicated. So how can we fix that? Another source of confusion is misleading error messages that occur when the user makes a mistake. For the example above, suppose that the second entry of V1 was supposed to be 2.2. So it should have been like this. But imagine the user makes a typing error and makes it 2:2, creating a 4x1 array instead of a 3x1 array. V2, let's assume, is the same, and then we call vecop one more time. Here we get an error message that looks like something went wrong inside the vecop program. At line 2 on the vecop program, some error occurred. From a user's point of view, it almost looks like the person who wrote vecop has made a mistake. Vecop is not performing properly. As a user, again, I need to do quite a bit of detective work to notice that in fact it's my V1 that was the problem and not the function vecop itself. It would be preferable if vecop did some checks on the data internally before it tried to make any computations. Let's return to the slides and address these two issues. Ever since we learned about script files, we've known that comments and blank lines can improve readability. So here I've modified vecop to vecop C and added a few comment lines. The first 2 lines describe what vecop does, computes dot product and cross products of 2 3x1 vectors. And then I have some comments within the code where the dot product is being computed, where the 3x1 vector is being allocated to hold the cross product, and where the cross product entries are being calculated. It didn't take a lot of work to put those comments in, and they'll certainly make the file more readable at a later date. How about error checking? Here's a new file, vecop E. There's one large conditional that checks 8 separate conditions before doing the dot and cross product calculations that we introduced earlier. First, the number of elements in V and in W is verified to be 3. Both V and W are checked to be real vectors. Both V and W are checked to be numeric. And finally, the column dimension of both V and W is checked to be 1. If all of those hold true, then the calculations are performed. If any of them is false, then a very clear error message indicating that the vectors were invalid and were not both 3x1 is displayed to the user. This type of error checking on the input values makes functions much more usable and assists users in more quickly finding their own errors. Let's go back to Matlab and try calling vecop E with the incorrectly dimensioned vector V1. Open the editor and look at the vecop E function, which has the error checking. Here, both V and W, the input arguments, are checked to be 3x1 real numeric vectors. Once that passes, then the dot product and cross product are computed as before. If the condition fails, an error message is displayed. If we try this on the data that should produce an error, rather than finding that the error occurs inside vecop on a particular calculation, the error message is very clear, stating invalid vectors, both should be 3x1. Now as a user, I've checked my vectors and I see indeed there's a problem with V1. Therefore, we conclude here that using conditionals to check the validity of input argument values is a very useful initial step inside functions.